So we're going to take a look at the homework quiz from section 11-5. That's right, we're talking about irrational numbers with variables, irrational variable expressions. So the first thing we're going to take a look at is problem number 12. Now in problem 12, we have the square root of 80n to the sixth. Well, we need to break this apart, and we're going to break it apart into its numbers, its numeral components, and its variable components. Now, the square, so that means the square root of 80 times the square root of n to the sixth is the square root of 80n to the sixth. So my next step is, what goes into the square root of 80 that is a perfect square? Well, obviously 4 does, and I'm willing to bet 16 does as well, actually. So I'm going to go with the square root of 16 times the square root of 5, because 5 times 6 is 30, carry the 3, 5 times 1 is 5, plus the 3 that we carried over, 5 plus 3 is 80, so we're 8, so we're good. So the square root of 16 is 4, just the integer 4. The square root of 5, well, that can't be reduced any further. The square root of n to the 6th, well, we know that n to the third squared is going to be n to the 6th. So that means n to the third times n to the third is n to the 6th. Therefore, the square root of n to the 6th is n to the third. So let's multiply together what the pieces that we have. So we have 4 and n to the third as our rational components. So we end up with 4 n to the third. And then our irrational component is the square root of 5. So you will get 1 point for the correct answer and 1 point for the correct work. For the next question, number 33, we have an equation with a square root. Now, we can do this one of two ways. We can solve this using a difference of squares. I'm guessing after yesterday, most of you would prefer not to do that. Or we can treat this more as a train track type problem. And so let's go ahead and do that. Now, the first thing I notice is 2m squared and negative 50 both share a factor of 2. So I'm just going to divide everything by 2. And this is not a factoring by 2, that the 2 doesn't end up on the outside of the parentheses, because I have an equation. And in an equation, I can add, subtract, divide, and multiply anything I want to one side as long as I do the exact same thing on the other. So I can divide everything by 2. When I divide everything by 2, I end up with m squared minus 25 is equal to 0, because 0 divided by 2 is 0. My next step, well, let's add 25, and so I get m squared is equal to 25. Well, what's the opposite of squaring? Square rooting. So I'm going to take the square root of both sides, and that's same basic idea as dividing everything, or dividing both sides, and so I'll end up with m is equal to 5. But wait a second, 5 times 5 is 25. But negative 5 times negative 5 is also 25. So I need to take into account that I have both positive and negative 5 as my answer. All right. Question, so we have problems, and this is problem, I believe, problem number 5. All right, the search for a missing boat covered a circular region with an area of 164 kilometers squared. Give me a second. Never make a video during passing period, I swear. It's not a good idea. All right, so what is the radius of the region? Well, geez, how am I going to do this? Well, it says a circular region, and I know a circle has an area of 164. Well, I know how to find the area of a circle. The area of a circle is equal to pi r squared, which means I just have to plug 164 in for the area. Okay, cool. So that means 164 has to be equal to pi times, you can work, times the Maybe the pen is not going to work. Radius squared. All right. Okay, well, pi is just a number, right? So I can go ahead and divide everything by pi. Now, it's an irrational number, but as irrational numbers go, it's actually pretty rational because pi is really, really, really super duper close to the number 22/7. 22/7. All right, so I'm going to pull up my calculator. And so we're going to go 164 divided by pi, that's 3.14, obviously 159, blah, 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 but I'm just going to round it there. And so I get 52.229299. That's interesting. I don't think it's going to repeat though. All right. So then I have 52. My pen really does not want to work today. Maybe over here. So we have 52.23 is equal to the radius squared. What's the opposite of squaring? Square rooting. So take the square root, take the square root. And so I'm going to squirt this, and I get the radius is equal to 7.23. All right, and I believe the instructions on your paper is to round to the nearest tenth, so actually it should be 7.2. It's always important to read the directions, I swear. Finally, so I'm sorry, talk about the points, obviously. You'll get 1 point for the correct work, and 1 point for the correct answer. And then finally, mixed review exercise. So this problem is a little bit different than the one we saw yesterday because we are using three rules of exponents. And just to review these rules of exponents, we know that, move this out of the way, give myself more room, we know that a to the x power times the same base to the y power is going to be equal to a to the x plus y power. Yes, this is going to show up really quickly in high school, so you cannot forget these. We also know that a to the x power taken to the y power is equal to a to the x times y power. We talked about that at length. Finally, we know that a to the negative x power, we know that negative exponents don't give us negative numbers, they give us fractions. And so that would be equal to 1 over a to the positive x power. All right, so looking at my problem, we have two monomials that are each being taken to a different power, and then we are being asked to multiply them. So what do I have to deal with first? The fact that I'm multiplying them, or the fact that I have an exponent? That's right. Please excuse my dear Aunt Sally tells us the exponents have to be taken care of first. So we're going to take 4x to the third squared to the second power. Well, 4 squared is 16. I'm going to rewrite this. So 4x to the third, we're squaring this. All right, is equal to 16. X to the third squared is going to be x to the sixth. For my second monomial, I notice that we have a negative exponent. Well, using my rule right here, that tells me that this whole thing would be equal to this. If I said negative 2x to the fifth to the negative third, well, that's just going to be equal to 1 over negative 2x to the fifth to the third, the positive third power. Okay, so we're going to get a fractional answer here. That's okay. All right, so negative 2 to the third is negative 2 times negative 2 times negative 2. Well, that's negative 8. So we have 1 over negative 8. Oh, that's nice because we have a 16 in the numerator. And then x to the fifth to the third, we multiply the exponents just like it says here. And so we're going to end up with I swear, I keep writing something, but it doesn't write. X to the 15th. And so, let's put these two pieces together. We have 16 x to the 6th divided by, because this is a fraction now, right? Negative 8 x to the 15th. All right, well, this is a fraction like any other. We can reduce it. 16 divided by negative 8 is just going to be negative 2. As for the variables, I have x to the 6th in the numerator, x to the 15th in the denominator. Which has more x's, the numerator or the denominator? That's right, the denominator does. How many more? Well, 15 minus 6, well, that's just 9. So we have x to the 9th. So again, you'll get 1 point for the correct work, 1 point for the correct answer. I hope that all of you have 8 out of 8.